Okay, so we're going to go over probability using fundamental counting principles. So we have your NS, which is the number of possible outcomes, which is divided by, I couldn't really put these the other way around, is the number of possibilities that fulfill what we're looking for, so the said outcome, right? So the way they wanted us to think about this question, they've given us a question that there are 8 friends, and the possibility T-Y, yuck. 8 friends, possibility that 2 have same birthday. So 2 same B-day. So the real way they want us to go about that is they want us to actually think of the possibility of people not having the same birthday as someone. So let's take a look at our 8 friends here. Okay? So we have friend 1, 2, 3, 4, 5, 6, 7, and 8. We're going on the assumption that, let's say this guy's birthday is January 1st in this case. Okay. Well, guy 2 now has the option of, and this is the not. So this is essentially our A prime. So this is the possibility of not having the same birthday. In the end, whatever our probability is, we're going to subtract it from 1. Okay, so we're finding the not having the same birthday. So in order for this guy, friend 2, to not have the same birthday as friend 1, he has a choice of 364 out of 365 birthdays, right? Friend 3, well, in order for him to not have the same birthday as the first 2 guys, he has the option of 363 birthdays out of 365, right? Which goes 362, 361, 360, 359, and 358. So it just took me a second to think through this. 364 factorial, which is essentially 364 all the way down to 1. Okay? But we want anything below 358 to be eliminated, right? We want all of those factors. So we really only want to multiply down to 358. Well, a way we could do that is to divide by factorial 357. Because what that will do is make anything from 357 down to 1 divided by 357 down to 1. They'll all essentially cancel each other out. And then we'll be left with just these terms here. Okay, so in case you get a very large one where you had to multiply like 40 of these in a row, like say it was out of like 50 students, something like that, this would be a way to simplify that in your calculator. So do you want to try that right now with your calculator? I know the one I have, I don't think it's the best for that. Factorials. 364 factorial overflow. Yeah, my calculator can't even deal with it.
Mine can't either.
No, yours can't either, right? Okay, so then we're going to have to just multiply this the old-fashioned way. 364 multiplied down to 358. So we'll do that right now. So I'll pause while we do that so we figure this out. Okay, so we jump through it quickly on the calculator. We've got a very large number like this. I'm going to divide it by 365 to the power of 7, which equals 0.925. So 0.925. Okay, but remember, this is the probability of not having the same birthday, right? So probability of not having the same birthday, well, what we want to do from there is we want to subtract that value from 1, because that will give us the actual probability of having that same birthday. So when we subtract that from 1, what do we end up with? 0.075. Yeah, 0.07. I got 74 or something, right? And I think when it rounded, 0.743, yeah. So we can round it to 0. Oh, I missed a 0. 0.074, okay? Which is exactly what they were looking for in this book. Okay, so a lot of thinking to go into set this one up here. Okay, again, this is, all of these will be over 365, these possibilities. So, and essentially the way to figure this out is we're going to figure out the probability of not having the same birthday as this guy. So this is a factorial that's kind of cut off. We're looking at the factorial of we want from 364 multiplied all the way down to 358. And because it's over 1, 2, 3, 4, 5, 6, 7 people, that's 365 to the power of 7. Okay, so this is how we go about figuring out with a calculator. So we'll use our calculator to do this. Are you able to go through this? I think we can set it up. Another way we could do it is the factorial of, when you're setting up factorials, let me just think through it quickly. It becomes a little complicated when we go through it that way. Let's say